In this video, we work on definition of continuous function and different types of discontinuity. Let's see when a function is continuous. Function f is continuous at x equals a if, number one, f of a is defined. Number two, limit of f of x as x goes to a exists. Number three, limit of f of x as x goes to a equals f of a. But a function that is not continuous has some type of break in graph. Let's see different types of discontinuity, like break, any break, like hole, jump, or vertical asymptote. Let me give you one example for each. Let's check continuous, one example for continuous. So continuous for all values of the domain. Just first I give you one example for continuous function. For example, f of x equals x squared plus 1. As you see, this function always is continuous and there is no break in this function. Part B, let's say, is this continuous at x equals 1 and is called point discontinuity. Okay, let me show you the example. F of x equals x squared minus x over x minus 1. Okay, first you factor your numerator, so is x times x minus 1 over x minus 1. As you see, we have common factor. When you have common factor in rational function and you can cancel it, then you expect to see a whole in that point. So your function is, simplified function is x. So let's sketch the graph, 1, 1. So this is your function, but you have whole at, let me use different color, you have whole at x equals 1. Let me sketch it here. So, sorry, just give me a second, let me use that color and just show you whole. We have whole at 1, 1. As you see, we have whole, and this case is called point discontinuity when we have a whole. Just we have discontinuity at one point. Part C is another type of discontinuity. You can say is this continuous at x equals 1 again at one point, but is called jump discontinuity. Is different than whole because in whole just you see in it, sorry, it's different than point discontinuity because in that case you see a whole. But for part C, jump discontinuity, you expect to see left and right hand side limit are different. You get two different values for left and right limits. Let me give you one example. For example, limit of f of x as x goes to 1 from left, as you see, is negative 1. But limit of f of x as x goes to 1 from right is positive 1. As you see, we got two different values for left and right, and limit does not exist. So in this case, we have discontinuity, and it's called jump discontinuity. Let's see last example, part D. Function is discontinuous at x equals 1 and is called infinite discontinuity. In some textbook you see vertical asymptote. So if we have vertical asymptote, then function is discontinuous at given point. For example, here we expect to see function is discontinuous at 1 because we have vertical asymptote at x equals 1. For example, this graph is discontinuous at x equals 1 because we have vertical asymptote, and also you can say infinite discontinuity because limit of f as x goes to 1 from right side is infinity, positive infinity, and limit of f as x goes to 1 from left is equal to negative infinity. But because it's infinity, limit does not exist. And also you can just say vertical asymptote and is discontinuous at x equals 1. Thank you so much for watching this video. If you have any question, please share with me.